Good afternoon, one and all. So this is the lecture number 36 in wireless ad hoc network, and we are almost at the end of the concluding, almost toward the concluding part of this module 4. So today we are going to see the three very important concepts. First one is the empirical energy consumption formula, how to develop it in wireless sensor network, because we have seen like ad hoc network, wireless sensor networks are also highly energy constrained. So in that case, how to save energy and what are the parameters that are actually causing the energy depletion in every wireless node, that we are going to find out. So first there is the empirical energy consumption formula development for wireless sensor network. This question can be asked for 10 marks in case of final exam. And then we will see a concept which is called as clustering. So some part of it we have seen in case of the second module during routing. Here also we will see the clustering thing in detail. And in some clustering we are actually forming something called as a cluster head. So all the sensor nodes are divided into few groups, that is called as cluster. And at certain times in certain topologies there might be a cluster head. So cluster head is a cluster node with sensing capability and with few more added functionalities compared to the other sensor nodes. So how to select a cluster node, how to select a cluster head, that algorithm or that theory we are going to see in the third chapter, in the third topic. So mainly there are two topics. First one is the empirical energy consumption formula in wireless sensor network, and next is clustering. And clustered selection is a part of clustering. So these are going to be our two topics for today, that is fourth and fifth topic. Sixth topic is application of wireless sensor networks. These are actually being done by you through the course seminars. You are bringing in front of us a lot of different applications, a lot of different technologies related to wireless sensor network. So fourth topic, that is energy consumption in wireless sensor networks, we will start it today. This is called an empirical energy consumption formula in wireless sensor network. The main idea in wireless sensor network is we are supposed to minimize the energy consumption at sensor node for communication, and this is the most critical design issue in case of wireless sensor network. So energy consumption happens mainly at three places, or mainly for three work in any ad hoc wireless node. First, for sensing some environmental parameter and converting the sensed signal into digital signal. So sensing and conversion of sensed signal into digital signal, there is a first step of any node, first work that any node does. So energy consumption happens there first, that is at sensing unit, and conversion of sensed analog signal into digital signal. Second thing is at communication unit for transmission and reception. So if sensing unit was the input unit to the node, communication unit for transmission and reception is the output unit of the node. And the last and the most important part of it is for computing or processing unit. So in sensors and ADCs, power wastage occurs, or power is dissipated. Secondly, for output side, that is the communication, transmission and receiving of any data, power is required. And lastly, in the mid part, that is between the sensor and the communication thing, in between the sensor sense data is being processed by the microcontroller that is there in the node. So that is the third thing, that is that computing or processing unit, power is required. So if too much data are being processed by any microcontroller, in that case power usage by the microcontroller should be very high. Okay, so that's why for light sensor nodes which are not used for too much of data transfer and all, so it will just sense the data and send it to the cluster head. For those kind of thing, this third, that is computing or processing unit, is not using much power. Okay, so this third stage is actually is very less in case of the normal type of sensor nodes. And for anchor nodes, this computing and processing unit is utilizing more power. Okay, and nodes, if they are kept at far distance, in that case communication and transmission and reception power will be more. That means if one hop distance is higher for any kind of communication, in that case communication power will be more. So these are the things we have to understand. So if one sensing unit is having 5 6 different types of sensors, that means same sensor node is sensing 5 6 different parameters. In that case, sensing unit will be utilizing a lot more power. Or if it is a sensor node only with a single sensor, that is a temperature sensor, in that case sensing power will be less. So multi-sensor data sensing, in that case at sensing unit, power usage will be more. Okay, so when the communication distances are more, and at that time the transmission and receiving power requirement will be more. If some sensor node is not only sensing but it is processing, it is taking some decision, it is sending the data back to the sync node. So more than sensing, if it is doing some few other jobs or processing related thing, in that case computing and processing unit will be requiring more power. So first you have to understand which are the main work that the sensor node is doing. So one fourth work with this you can add, that is some sensor nodes which are mobile. Some sensor nodes can automatically move depending on their initial position. So while tracking the target, it can move. So if it is in the land, it can move by means of a wheel. If it is in the air, it can move by means of a wing. Or if it is in the water, it can move by means of a flagella. So in that case, this automatic movement can occur in the sensor nodes. So in that case, so there is a mobility unit. So that mobility unit also will be using some kind of power. So that is a special kind of sensor node. So that is a fourth point you can add here. That is, in case of special kind of sensor nodes with mobility either in the air, water or land, in that case for mobility of the node also some major amount of power will be required. Okay. So these are the main four cases where the power requirement is there in any sensor node. So mostly the sensor nodes are put to idle state or put into sleep mode or inactive mode to conserve the energy. So as long as the communication is happening, it is in the active mode, but as soon as the communication is over till the next communication, it is in latency mode or it is in idle mode or sleep mode or inactive mode. Okay, because this is saving actually a lot of energy, and this energy saving actually helping the node to save some of his battery power. This will increase the node lifetime, this will increase the network lifetime, because once we deploy the sensor nodes, we cannot go to change the battery. Sensing transducers, it captures the physical parameters and nodes and does signal sampling. This is a part of the sensor node that consumes least energy among others. So there are mainly three parts. One is sensing, one is processing, one is communication. Among these three, sensing actually uses least power. That is what it is mentioning, that the sensing transducer, it captures physical parameter and does signal sampling. Sampling is done because this is the first step of digitization. So whatever data is sensed by the sensor, this is the analog data. Now this data has to be converted to digital, because whatever microcontroller is there inside the node, this can only process digital signals. So analog sense data has to be converted to digital, and sampling is required as the first step to digitization. So sensing transducer, whatever power it consumes, this is least among the three main units of power consumption, that is sensing, processing and communication. AD converter, A to D converter or ADC consumes 3 to 5 microwatt power in active state and around 40 picowatt power in idle state. So just see how very small amount of power is being consumed by the ADC. So when it is active, that means converting analog into digital, it is consuming 3 to 5 microwatt power, the ADC unit, and when it is idle state, it is actually using 40 picowatt power in the idle state. So parasitic capacitance and reference voltage of ADC are the main design parameters. So we know what is parasitic capacitor, and reference voltage is something which is determining the resolution of the ADC. So parasitic capacitance and V reference, that is the reference voltage, are the main ADC parameter that we have to keep in mind. So now transmission energy, so this formula is to be understood. So transmission energy, that is the energy consumed for transmission of k bit messages to a distance of d. So that's why it is called as ETX. ETX stands for energy for transmission for k bit over a distance of d. So that is the significance of this. Exactly this way you should write the formula. So if we want to transmit k bit of messages to a distance of small d, then how much will be the total power consumed in that case? So first is ETX elect K. So that is the transmission energy consumption. That is for transmission of the energy, this much is required. This 50 nanojoule per bit. So if there are K bits, that means this will be 50 into K. So this will be 50K. Okay, for K bits. Okay, because this is transmission energy consumption. It is 50 nanojoule per bit. So if it's a K bit transmission, it will be 50K nanojoule. Sorry. Next is ETX AMP. Okay, so whatever amplifier is there inside the sensor node, that amplifier is actually using some amount of power. Okay, again the same thing. This transmission amplifier energy for k bits over d distance. It is given by ETX amp. TX stands for transmission, AMP stands for amplifier. Now the formula is actually given here. So what is ETX elect K is given. So it is E elect into K. So E elect is nothing but 50 nanojoule multiplied by K. So this will be actually 50 into K nanojoules. And whatever is this transmission amplifier power, this is given by this symbol multiplied by K into D square. So this is E amp into K into D square. So this is epsilon into K into D square. What is K? K is the number of bits, and D is nothing but the distance over which the K bit is to be transmitted. So this E amp is a proportional constant. This is given by 1000 picojoule per bit per meter square. That means if you want to transmit 1 bit energy for over 1 meter square area, in that case 100 picojoule will be required. So in this case we are transmitting 50 sorry k bit over d distance. So this will be 100 picojoule into 50 into into k into d square. So whatever is here, this is the multiplying constant multiplied by k multiplied by d square. Okay, that will be the energy. So this is the transmission amplifier energy, and this first part is the transmission energy consumption. So the transmission energy, and this is the amplifier energy. Receiver energy, so to receive also, so this much energy is required. So this ETXKD, this is the energy required to transmit k bit of signal over distance d. Now when k bit message is received, at that time also some amount of energy is required. So that is given by ERXK. So RX stands for receiver and K stands for k bits. That means any node, when it is receiving a k bit of energy, k bit of message, then how much energy it is going to use. So it is called as ERX of K. That is equal to ERX elect into K, that is E elect into K. So E elect again will be given something like this, and it will be a lot less than 50 nanojoule per bit multiplied by K. Let's see what is meant by a computational energy. So this previous thing was for transmission energy, previous thing. So this was for transmission energy, this was for receiver energy. So these two were actually the third part. So we have seen, second part. So we have seen that first there is the sensing unit, so sensing transducer and AD part. So these two, sensing and AD, this is actually to the number 1. Okay, and this last part, transmission energy and receiver energy, this is actually the second part. There is a communication unit energy usage. Now we are coming to the third part, that is computing or processing unit. For computing, how much is the energy required? So microcontroller with memory controls the operation of sensing, signal processing and communication. It has mainly two parts in consumption of energy. First one is switching energy and second one is leakage energy. So switching energy is nothing but between on off. Okay, and leakage energy means some energy is wasted because of thermal voltages, because of the other processing parameters. So that leakage energy and switching energy, how much is that? That we have to find out. Okay. So here we are finding switching energy is given by E switch. So this C total is nothing but a proportionality constant, is the total capacitance switched by the computation. So you have heard of switching capacitor. So this concept is used here. So this is that C total, and VDD square. VDD is nothing but a supply voltage. So more is the supply voltage, more will be the switching power that is required to turn on, to turn off, or turn off to turn on the overall node. Okay, so E switch, so the small formulas you have to remember. So E switch is equal to C total into VDD square. So more is the reference voltage, supply voltage, more will be the energy wasted in the switching, that is from on to off and off to on. Last is leakage energy. So how much is the one energy this is leaked? This is given by VDD. VDD is again the same thing, supply voltage or the VCC multiplied by T. So T is nothing but time, I naught into e raised to VDD by eta VT. So this is kind of a diode formula. So diode current formula. I naught into e raised to V divided by eta Vt. Okay, where Vt is the thermal voltage and I naught and eta are processor parameters. So E leakage, so leakage power is nothing but voltage into time multiplied by current, and this current is actually exponential current. So whenever we are finding voltage into current, this is actually giving us energy, and whenever this is multiplied by time, so this is giving us power. Power multiplied by energy is power multiplied by time is nothing but energy. So there's the leakage energy, and this is nothing but VDD into T whole into I naught into e raised to VDD by eta VT. So for strong ARM SA100 processor, eta is equal to 21.26, I naught is equal to 1.196 milliampere. So for a certain processor, all these parameters with units it is mentioned. Now something which is called as residual energy. What is meant by residual energy? Residue means when something is remaining after use. Okay, so a bucket is full of water, we have taken bath, and after that maybe 2-inch height of water is pending in that bucket which is not used. Okay, so that is actually towards the bottom of the bucket, so that is actually called as residue. So what is residual energy? Sensor node gets power from battery. After consuming the energy by all functional units of sensor nodes, the remaining energy in the battery of the sensor node is called as residual energy. So initially we have charged the battery to the full of any node, and node has been working after for maybe 5 months or 6 months, and after that also some energy is remaining in that sensor node. Okay, so that energy is called as residual energy. So more is the residual energy in any node, it is better. That means it has used a lot of proper power saving algorithm to save the power for future use. So this decides the further lifetime of sensor node and network. So at the end of the day, the residual energy of any sensor node is calculated, and that information is sent back to the other nodes, because we have seen that energy based routing, whenever the data routing is taking place, the all the residual energy in all the nodes within the network is first known, and depending on that a table is created. So if some node are having high energy, that node is used in case of routing or planning for path. If some node is having residual energy very less, in that case that node will not be taken into any kind of routing or planning of routing. So that's why this residual energy is a very important parameter for any network or any node. More is the residual energy, chances that that node will be included in next routing of data from source to the receiver. And last thing, last definition is sleeping. So what is meant by sleeping? Sensors are put into sleep wake cycle. So here the switching happens. Okay, whenever it is going from on to off or off to on, switching happens, and every switching actually takes some power. That power is wasted. So sensors are put into sleep wake cycle or active inactive cycle to save battery power, because continuously if it is on, it will be wasting a lot of power. So that's why latency comes into picture, and between two transmissions actually the node goes into off state. So when sensor is in the sleep or idle state, it turns off few internal subsystems to save power. So communication subsystem is definitely off, sensing subsystem is definitely off, microcontroller is just for station keeping, it is kept on. That is, it is like the heart of our body. Okay, even if you are sleeping, the heart is also beating, so just to keep the body alive, the heart is pumping. Samely, whenever the whole node goes into sleep mode, then just the microcontroller somehow is maintaining the basic operations. The timekeeping and date keeping, all other things is being done by the microcontroller, even if the whole node has gone into sleep or idle state. So it turns off internal subsystems to save power. There are many types of sleep modes and many strategies to save the node power. So these are the two basic understanding of empirical energy consumption formula in case of wireless sensor network. Why to save power? First you have to explain. So save power is because we cannot go every time into jungle or places, difficult places where the nodes are deployed. So we cannot go there every time. So once we have deployed it, it should be left there for months or maybe year. Okay. So that is the first thing. And why sensor wireless sensor network energy saving is required. That is the first thing. Then which are the parts in WSN node they are using more amount of energy. So it is for sensing, it is for communication, it is for computing. Then step by step you explain all these things. So first we have explained sensing and ADC. This actually uses least kind of power. Then we have talked about transmission energy. In transmission energy, the formula of ETXKD, that is to transmit k bits of data for d distance, how much is the transmission power required, and how much is the receiver power required to receive k bits of data over a distance of d, that is also explained. Finally, we have to give some comment on the computation energy. So more number of execution, more number of operations the microcontroller node perform per second, actually that is directly proportional to the power consumption by the overall sensor nodes. So very powerful microcontroller, they can do many calculations in 1 second or within a specific time. So very fast they give result. But what is the downside? Downside is it is actually eating up a lot of processing power. So how to find the processing power? So switching power is switching energy is actually one energy that is there related to processor. Leakage energy is also another energy related to processor. And then there comes two things. One is called as residual energy. One is called slipping. So more is the residual energy, more will be the chance that the node will be again considered for routing in the next step. So less residual energy means that node will not be picked up for routing purpose in the next step or data transmission purpose in the next step. And slipping is inactive or idle or latency. You know what is the use. So by slipping or making the node inactive, we are actually increasing the lifetime of the node. And a very important data given here, that is the node actually consumes 3 to 5 microwatt power in active state while sensing and 40 picowatt power at idle state in sensing. Okay, so these were all about the power or energy related information. You can find some more in the book of Cordeiro given. Just go through that. Next, what we are going to see is clustering of sensor nodes. So whatever time we have today, we're going to see what is meant by clustering. So energy consumed in wireless transmission is proportional to the square of the distance between the sensor nodes and the destination of the cluster head. So I told you that if there is an area and that area is suppose sensed by 4 small sensor nodes, each sensor node is fitted with some temperature sensor. So all the 4 different sensor nodes are sensing the temperature over the whole area and sending it back to the cluster head. So within that area there are mainly 5 nodes. 4 nodes are basic sensing nodes, temperature sensing nodes, and 5th node is sensing plus processing. So that 5th node is having a little bit higher capability. That is actually the cluster head. So this cluster head actually is kind of a teacher for the other 4 nodes. The cluster head actually governs the other 4 nodes. The cluster head actually receives the data from all the 4 nodes and sends it to the base station after a little bit of processing. So that is very important. So energy consumed in wireless transmission is proportional to the square of the distance between the sensors and the destination of the cluster head. That means if distance is 4, in that case power wastage power required will be 4 square, that means 16 unit. So that is what it is said. So distance is 2 means power usage will be 2 square, that is 4 unit. So it is desirable to partition the wireless sensor network into clusters and distance d, which can be defined as all sensor nodes in the cluster reachable by a path length of ch is less than to equal d. That means if there is a big area and suppose we want to govern that big area, what we are doing is we are dividing that big area into small different areas. And in every of those small different areas, we are deploying some 3 4 or few sensor nodes, basic sensor nodes, and one cluster head. That means the whole one country we have divided into states, the states we have divided into districts, the districts we have divided into taluka. What for? This kind of distribution actually helping us better governance. So it is the same thing within a very big area of sensor network. The sensor area is divided into smaller sub areas, and each sub area is comprising few normal sensor nodes and one cluster head. So cluster head is having a little bit more stronger microcontroller. Cluster head is having a little bit more memory capacity. Cluster head is having a little bit more energy, and job of cluster head to collect all the data from the basic sensor nodes, do little bit of processing, not too much of processing, make the data more compact and send it to the base station. This is the job of cluster head. So it is desirable to partition the wireless sensor network into clusters with distance d. So, what should be the criteria of defining clusters? The criteria of defining cluster should be the nodes and the cluster head should be in such a way that distance between all the nodes to the cluster head is actually d, where d is the one hop distance defined for every node within that network or every cluster node within that network. So it is desirable to partition. Partition means segregate. Partition means distribute the whole WSN area into clusters with distance d, which can be defined as all sensor nodes in the cluster reachable by the path length to cluster head less than or equal to d. That means from every sensor node, distance of cluster head should be equal to d. Okay. And d is not a very big area. D is not a very big distance. D is actually a small distance. There is a single hop distance between normal node and cluster head. Determining optimal value of D minimizes the overall energy consumption for communication. So if you are keeping D very big, that means the size of the cluster also will become very big. Number of sensor nodes required in that cluster will be small. In that case, the accuracy also will be small. Okay. So if we want higher accuracy, in that case, number of sensor nodes within an area should be as many as possible. So as the number of sensors increases within an area, the distance for communication between cluster head and the sensor node, it reduces. So that is what is told here. That is determining the optimal value of D. What should be the minimum and what should be the maximum value of D? Between them, there is a optimum value of D. It minimizes the overall energy consumption for communication. Amount of data to be transferred within the cluster and between two clusters is very important parameter for cluster design. So generally, if there is a cluster head and if there are 4 different sensor nodes, so 4 different sensor nodes senses temperature in the whole area, and they, without thinking, they directly dump all those 4 sets of data into the cluster head. Now then, cluster head, depending on the position of each sensor node, it mixes the data and it kind of prepares a overall temperature map of the whole cluster for which it is deployed. And one cluster head will talk to directly the cluster head of next cluster. Cluster head is not going to talk to the sensor nodes of the next cluster. Cluster head will talk to the sensor nodes only within its own cluster. So amount of data to be transferred from the cluster head to the sync node, it happens through the 2 different cluster heads. Okay. And this is a very important type of communication. It is kind of a hotline based communication like that. So frequency of data transmission between the 2 cluster head, maximum allowable latency, local computation to be done before cluster head, and maintaining or storing a partial database information within the cluster are other design parameters for a cluster. So this is a very important discussion. That is, what are the important parameter for clustering? That is frequency of data transmission between 2 clusters. Okay. Then maximum allowable latency. How much is the maximum latency that can be allowed? That means for how much time a node can be kept inactive. That is a very important design parameter for any cluster. And then local computation to be done by the cluster head. Okay. And maintaining or storing a partial database information within the cluster are the design parameters for a cluster. So we are actually storing or maintaining a kind of a table, data table in case of any cluster. So cluster means 3 4 simple nodes and one cluster head. So as thousands of sensor nodes are deployed close to each other, the information from sensor nodes within a cluster is redundant. So this is what I had explained to you previously. Because if there are four sensor nodes within a small area and there is one cluster head, so all the sensor nodes might be sensing the same temperature. In that case, suppose all the 4 5 sensor nodes are sending the data back to the cluster head, and cluster head finds that all the 4 5 sensor nodes within that cluster is having same temperature. So what is the point sending all the 4 5 communication to the cluster head? So only one sensor would sense and send the data back to the cluster head. This was enough. Okay. So there is a lot of power wastage if the algorithm is not designed properly. So as thousands of sensor nodes are deployed close to each other, the information from one sensor and the other sensors, that means all the sensors to the cluster, is redundant. So here the cluster head filters out the data received from all nodes within the cluster. So in that case, cluster head tells that as all the 4 5 sensors are sending me the same data, no need to send all the 4 5 temperature data to me. So in that case, cluster head will tell only one sensor node within the area that okay, you send me the temperature data. So in this case, this is the way we are actually reducing the communication power or communication energy. So here cluster head filters out the data received from all nodes. So filters out means after all the data is received, then cluster head is discarding some data. Okay, so in this case, power wastage is happening and the data is being filtered. So instead of doing that, let not clusters send the redundant data to the cluster head. That we have to be careful. So instead of filtering out the data and deleting the data later on, let us not send the data itself from the beginning, because sending data again is wasting a lot of power. So one or two sensor nodes will be sending the data to cluster head, remaining all other nodes within the cluster will be idle. So drawing the inference by using the cluster head is a costlier solution, but it gives almost optimal solution. So the job of cluster head is to mix all this data from coming from all the different small next level sensors and to draw an inference. Inference means exactly temperature is too high, temperature is too low, or some decision further has to be taken. So this job is actually done by the cluster head. Sensor nodes within each cluster is assigned a different time slots, which is called TDMA. It helps to avoid collision among sensor node data packets sent by sensor nodes to the cluster head. So whatever nodes are sending the data to the cluster head, they are actually using the TDMA method. That means one sensor at a time would be sending the data to the cluster head. So one sensor one is sending the data to the cluster head, all other, so there may be 50 other sensors. So all other 50 sensors, they are actually sitting idle. So one node at a time send the data to the cluster head, remaining other nodes will keep silent as long as node 1 is transmitting. So sensor nodes within each cluster is assigned a different time slot by the cluster head, which is called TDMA. It helps to avoid collision among sensor node data packets sent by the sensor node to the cluster head. Adjacent clusters use either a different frequency channel, which is called as FDMA, or a different code. So I told you that there are mainly three types of multiple access. First one is time division, next is frequency division, and third one is code division multiple access. So within one cluster, we cannot use the same frequency or same time two times. We cannot do that. So same frequency cannot be used within the same cluster, but two clusters which are actually segregated by from communication point of view, two different clusters can use the same frequency for their internal communication. But when one cluster is talking to another cluster, in that case, you cannot use that common frequency. So that is the same thing that is said here. Sensor nodes within each cluster is assigned a different time slot by the cluster head. So in this case, frequency is not shared. In this case, time is shared. It helps to avoid collision among sensor node data packets sent by the sensor node to the cluster head. Adjacent clusters use either a different frequency channel FDMA or a different code that is called as CDMA. So this slide you have seen already, so you can see the whole area. Okay, so this is a base station, so all the data about every area. Okay, so this may be the cluster head at the center. So all the smaller nodes, they are sending the temperature data back to this cluster head like this. Okay, and cluster head actually is talking to the base station. Likewise, this also is another structure. So here, this may be the cluster head. So all the sensor nodes are talking to him, and all the sensor nodes are talking to him likewise. And after it understands that it has received all the data, then in the next stage, this data will be sent to the base station. So here actually four clusters are shown and four cluster heads are shown. Generally cluster heads are toward the center of the overall network. Generally it is kept like that, but no hard and fast rule. So clustering of sensors not only allows aggregation of sense data, but it limits the data transmission primarily within clusters. And hence it reduces the traffic and the contention for channel. The clustering also reduces the data packet collision in channel. So this first 2-3 paragraphs are very important. They are actually talking about the basics of clustering. So the process starts with network discovery by sending periodic beacon signal. That means after all the nodes are deployed within the area, then each node tries to find out its own location. That is actually called as network discovery. So in that case, after the network discovery happens, all these nodes are actually sending the data back to the local cluster head or to the base station if base station is in access for all the nodes. Okay. So after every node finds its own location, it tells the base station or it tells the cluster head, yes, this is my position. Now I can sense data. Because sense data without the location information is a wrong data. Okay. So location information must go first, or the ID of the data must go first, and then comes the actual temperature or actual parameter that we are sensing. So the process starts with network discovery. That means as soon as all the sensor nodes are deployed, they try to find out what is their reference location. That is actually the uh, network discovery process. And there are many methods. So beacon signal based network discovery is one of the important thing method that they are proposing. So the periodic beacon signal, it helps in detecting neighbor sensor nodes and some of intermediate sensor nodes. So these are attributes of beacon based signaling. You can read that. Okay. So all these nodes forms a cluster and a cluster head is chosen. So cluster head, sometime it is designed from the first. It is a little bigger node with some kind of higher microcontroller capacity, higher memory, higher processing power and all. Sometimes if we are deploying 5 nodes within an area, one node will start taking the advantage of the position, and one node will be better than other 5. It is possible because of its positional advantage, or maybe because of its hardware advantage and all these things. So we have seen that some person is there who always suffers, who is always having some kind of sickness, and there are some persons who never fall sick. Okay, so what is the reason? Reason is nothing but the internal design. And sensors also, it's like that some sensors are very strong. In that case, for transmission and reception, less power is required. For them, during latency, almost it is zero power and all those things. Okay, so that node can be acting as a cluster head. So here we are actually discussing about how to select the cluster heads and how to do the clustering. So very important discussion. It is saying that clustering of sensor nodes. Okay, why clustering is required? Because of distributed control. We cannot control every sensor node. We cannot control every data sitting at one position at base station. So the king is sitting at base station, and these are the areas which are to be dominated by the king, or which are to be ruled by the king. So what the king will do is he will create some local cluster head or local leaders, and these leaders will be taking care of the each area, okay, separately. And that way the king is sitting at the home, but he also is getting to know all the information from the all the fields. Okay, so first all these different small sensing nodes, they send the information to cluster head. So all these are small sensing nodes like this. They will send the information to cluster head. All these 5 different, so these are mesh topology kind of thing. All these 5 different sensors will send the data to the cluster head first, and all these 5 different sensor nodes, they will be sending the data back to the base station, and then base station will relay the cluster head, and then the cluster head will relay the data to the base station. So the process starts with network discovery. So first line, clustering of sensor nodes not only allows aggregation of sense data, but limits the data transmission primarily within clusters, and hence it reduces the traffic and contention for channel. It also reduces data packet collision in channel. Mind it, all these five nodes will be sending the data to the cluster head only. These five nodes are not going to send the data direct to base station or to the other clusters. No, that is not that is not allowed. That is prohibited. That is what it is saying. Clustering of sensor nodes, it allows data aggregation only within the sensed area, that is the distributed sensed area. It limits data transmission primarily within cluster, and hence it reduces the traffic and contention for channel, and it also reduces data packet collision in the channel, because packet transmission between two different clusters are not allowed. The process starts with network discovery by sending periodic beacon signal. It helps in detecting the neighbor sensor nodes and some intermediate sensor node. All those nodes form a cluster, and a cluster head is chosen. Okay, so how to choose a cluster head, we will see in the next slides. Performance parameters are decided about how to group the adjacent sensor nodes and how many such groups will optimize the overall wireless performance. Now, this is a very important thing. There are 60 students in my class, and I want a better control over the class. So I will divide the 60 students into a group of 10, or group of 5, or group of 3. That depends on how good I am or what kind of outcome I want. So how much should be the number of nodes in every cluster? That depends on how well the base station would be able to control them. So if we are putting less number of sensors in every cluster, in that case communication will happen between all the nodes within that cluster very properly. So you can sense the data very accurately. But in that case, as number of nodes within the cluster is very small, many communication links will be created, and that will be sent back to the base station. So that will be a problem. So base station will get jammed. So only 2 or 3 nodes per cluster if you are keeping like that. So it will be accurately data sensing network. But whenever all the sense data are sent back to the base station will get jammed, and base station will behave in a different erratic manner. So this is a very important thing. On the contrary, if you are taking very large number of nodes within the network or within any area, in that case also we are going to sense it properly. But in that case, it will be too much of power consumption within the network area, because we have seen that within the same area, if there are many sensors, their data is generally redundant. Okay. So we are wasting a lot of power sensing the same data over and over within the same area. So minimum number of sensors, maximum number of sensors within the cluster is actually a mathematical problem. So it depends on the area, it depends on the strength of the cluster head, strength of the nodes, and all other things. So the process starts with a network discovery by sending periodic beacon signal. So network discovery means nothing but all sensor node comes to know about its own position after deploying. That is called as network discovery. So the process starts with network discovery by sending periodic beacon signal. It helps in detecting neighboring sensor nodes and some intermediate sensor nodes. All these nodes forms a cluster, and cluster head is chosen. Performance parameters are decided about how to group the adjacent sensor nodes and how many such groups will optimize the overall wireless sensor network performance. So whether you are going to divide the whole area into 10 or 20 cluster with a smaller number of cluster nodes, or whether you are going to divide the whole area with maybe 5 cluster with large number of sensor nodes, that is actually the optimization problem. So one approach is to partition the wireless sensor network into clusters with those many sensor nodes who are directly attached to the cluster head. So the first approach is design the cluster head first, and within the single hop range of the cluster head, whichever sensor nodes are there, so that cluster head and this single hop sensor node with that cluster head, mix them and form a cluster. Sensor nodes in the cluster directly transmit data to the cluster head without any intermediate or peer node. So there is a direct connection between the sensor nodes and the cluster head. This minimizes communication energy within the sensor node cluster. And all the cluster heads communicate with each other for information collaboration. So that kind of a hotline kind of a communication. So here different types of clusters are explained. So this slide is also shown in module number 2. So first type, you can check the cluster head is at the center. So cluster head is also called as a pan coordinator. Okay, and in this case, all these are different fully functional and reduced functional device. So this is the coordinator. This is at the center, and green nodes, they are fully functional devices, and blue are reduced functional devices. So within this small six node network, we have actually divided the functionality into three different tier. So tier 1 is pan coordinator, that is the highest. Tier 2 is fully functional devices, that is the green nodes. And tier 3 is reduced functional devices, that is the blue nodes. Okay, so all these are actually defining different hierarchy. All these are actually for reducing the power consumption and for better controlling. Second case, you can check tree. So all the pan coordinators, they're actually forming a tree. So this are the pan coordinators, they're forming a tree. And from every cluster head or every central point, there is a pan coordinator, there is a small tree which is coming out. And there's a mesh, all the nodes are connected to every node. So there's a most complex kind of a thing, and this is actually a mesh topology. So these are different topologies that we find in case of clustering. So nodes in ad hoc wireless network often need to organize themselves into cluster for better control. Clustering allows hierarchical structures to be built on the nodes and enable more efficient use of constrained or scarce network resources, such as frequency spectrum, bandwidth, and node and energy power. If cluster size is equal to one hop of a sensor node distance, then much simpler protocols can be used for routing and broadcasting within cluster. That is actually star network architecture. Same time, the time division multiplexing or same frequency division multiplexing can be reused across non-overlapping clusters. That means whatever frequency we are using for this side for frequency division multiplexing, next in another cluster, the same kind of frequency may be used for transmission. Okay, but within same cluster, we cannot use the same frequency. Okay. So same time division or same frequency division multiplexing can be reused across non-overlapping clusters. So there is no overlap in this cluster, but yes, overlap is there in this cluster. Network can be comprised of mixture of nodes, including some that are more powerful and have special capabilities such as increased communication range, GPS. These more capable nodes can be naturally play as the cluster head roles. So clustering also allows the health of the network to be monitored, and misbehaving nodes, if there are certain nodes which are not functioning properly, they are called as misbehaving nodes. You have to understand them initially as fast as possible. So we should not assign the role of cluster head to one of these misbehaving nodes. We should be careful. Okay, some nodes in a cluster can play watchdog roles over other nodes. Cluster heads may also act as the watchdog node. Okay, so watchdog node is which sensor is which node is on at what time, which node is off at what time, which node is having latency for how much time. All those things can be tracked continuously by the cluster head. So these are the jobs of cluster head. So how to select a cluster head? This is a very important question. A node which has largest neighborhood connectivity among all nodes within the cluster is selected as a cluster head. So a sensor which is generally residing at the center of an area, this is actually connected to all other nodes with a one hop distance. In that case, this thing is having highest or best connectivity. This thing will be acting as a cluster head. Okay. A node which is connected to maximum number of neighbors, cluster heads may be selected as a cluster head. The first thing is a node which is connected to maximum number of simpler sensors can be selected as a cluster head. A node which is connected to many other cluster heads, okay, so he can be selected as a cluster head. Cluster head aggregates data received from its cluster members, that means which are simpler nodes, and from base station. Hence, the cluster head is usually trusted with the transmission schedule to its members and BS. So BS is nothing but base station. So this is the base station, and these are other members. So there are three tiers. There are three important levels in this network. So these are very simple nodes like this. They are having very simple controller and simple processing power and all these things. This is very simple node. Okay, and then all these such simple nodes are informing or are actually they're talking to this central, or they're reporting to this central node. The central node is having actually a little bit more power. Central node is having a little bit more energy capability and all. So hence this central node is called as a cluster head. So third point, it is important, that is a node which is connected to maximum number of neighbor cluster heads may be selected as a cluster head. And cluster head aggregates data received from all its cluster members, that is simpler nodes, and from the base station. Hence, cluster head is usually trusted with the transmission schedule to its members and base station. Clusterhead does many functions. Its energy drains out faster than other node energy. So it is not only doing the data transmission, but it is doing data sensing, it is doing data processing, it is taking some decision. So cluster head is actually doing a lot of bigger, higher level functions, because cluster head is in between the base station and the simpler sensing nodes. So that's why cluster heads are actually wasting some more energy, and we are finding that cluster heads are actually coming to the zero state or zero energy level very fast. Yeah, so that is a negative side of cluster head. We have to remember is cluster head gets discharged very fast. So this is one diagram you have seen, I think in the second module you have seen, that we want to send the data from the source to the destination. So first we send the data to the cluster head, and cluster head, then inter-cluster head communication is there, and through that the data is actually transmitted from the source to the destination. Okay, so the other nodes in the other network, they don't know about it. So you can see that this red is actually the signal flow, and very fast it flows, and actually it sends the data from the transmitter to the receiver very fast. Okay, so there is a cluster head. So there are different types of heads which are explained here. So the central one is cluster head, the green one is sensor nodes, the yellow one is gateway path and other thing. Likewise, so here are different two structures. So the first one is the star network architecture, and second one, this architecture we have shown here, you can check, you can check here. So this is a kind of a tree structure architecture we have shown here. So this is the first one is star, second one is kind of a tree structure, hierarchical kind of a structure we are finding here. This diagram also you have seen. So you can see there are three there are two red cluster heads, there are three blue cluster heads, and there are five different green cluster heads. So depending on different distances, so here it is spectrum structure, and here number of cluster heads are more, distance between the cluster head are less. Here actually it is chain structure. Here each cluster head can tackle more amount of base data. Okay, each cluster head can tackle more number of sensor nodes likewise. Okay, so there's a chain structure, and the first one is actually a spectrum structure, and this is actually Voronoi structure. So yesterday we have seen Voronoi diagram. So if these are two polygons, then you have to place this sensor in such a way that this distance, okay, is equal to this distance. This is actually Voronoi diagram. Please prepare that. So Voronoi diagram is actually used for clustering. So it is chain structure of clustering, it is spectrum structure of clustering, it is Voronoi diagram based clustering. So why clustering is required? Again, the same thing is explained here, and this is the last slide, I guess. In this case, what we are showing is different types of clustering. So this is hierarchical clustering, and this is kind of a tree-based clustering that we are seeing. So here I finished what all I had to teach in this module number 4, and only thing is remaining is different